Hello everybody, welcome to my channel Science Simplified. Today we are going to learn about balancing chemical equations and the law of conservation of mass. Hope you guys will enjoy. So, before we get things started, what is a chemical reaction? Basically, a chemical reaction is a process that substances react with one another. And at the end, we get new substances that have very different characteristics and compositions. For example, we have burning wood. Okay, we have wood and thermal energy reacting with each other to make ash and smoke. That is a chemical reaction. Why? Because we are getting new substances that have very different uh, compositions and characteristics. Ash and smoke that we get at the end are very different from wood and thermal energy. Or rusting metal, or just rusting iron, taking iron as an example of metal. Iron and oxygen react with one another and it creates oxidized metal. Oxidized metal is, or oxidized iron, I should say, is much different from normal iron. Oxidized iron has a color of orange. It's orange. It's really fragile and breaks pretty easily. But iron, in its just natural form, it's kind of like silverish, grayish color. It is not fragile. It's strong. It bends and things like these. Or in photosynthesis, it's a really great example. We have sun's light energy plus CO2, carbon dioxide, plus water. We get sugar and oxygen, O2. Basically, sun's light energy, carbon dioxide, and water go through a chemical process. At the end, we get sugar and oxygen. Now, of course, there are many other chemical changes around us. Cooking egg, exploding fireworks, digestion in our body, using a battery, many more. But these are just a few good examples of chemical reactions. Now, before we go deep into chemical reactions, we have to talk about what reactants and products are, okay? So we have two chemical equations here. This is called a chemical equation. Basically, we have substances that react with one another, obviously, and at the end, we get a new substance with different chemical compositions, right? The substances that react with one another are called reactants, which are always on the left side of the arrow. So in this case, H2 and O2 that are going to react with one another are the reactants of our chemical reaction. And H2O, which is now on the right side of the arrow, is our product. Water is our product, and products are always on the right side of the arrow. Now, if you're wondering, this chemical reaction is the process of making water. Now, the chemical equation below, this is photosynthesis, right? Sun's light energy plus carbon dioxide and water are the reactants here. They react with one another to give us sugar and oxygen as a product on the right side of the equation. So this is basically, it's pretty simple. Reactants react with one another on the left side to give us products on the right side of the arrow. It's pretty simple. Now, law of conservation of matter, law of conservation of mass. Okay, we'll get to why it's really important in chemical reactions and chemical equations. But what does it say? It says that substances are neither created or destroyed in chemical reactions, meaning that we can't really destroy or create anything in the chemical reactions, meaning that the total mass of products should always equal to the total mass of the reactants. So we have, for example, 10 kilograms of reactants. At the end, we must always have 10 kilograms of product as well. If we don't, then something is gone wrong, or it just shouldn't be possible. We take a look at this example down here. This is again a process of making water. So if we look at it, we have 4 molecules of hydrogen. 2 times 2 equals 4. Pretty easy. So 4 molecules of hydrogen on the left side. We also have 4 molecules of hydrogen on the right side. Makes sense, 4 and 4. We have 2 molecules of oxygen on the left side. We also have 2 oxygen on the right side. So there's a balance here, and the law of conservation of mass has been followed, because in total we have 6 molecules on each side, right? 4 and 2, 6. 4 and 2, 6. There are equal amounts of products and reactants on both sides. Now, this is a great example in simpler words for law of conservation of mass, right? So we have 31 kilograms of reactants, 30 kilograms of wood or log, and 1 kilogram of fire, for example. So 30 plus 1 equals 31. And we have 28 kilograms of ash plus 3 kilograms of smoke. 28 and 3 equals 31. So let's just write here. Obviously, this equals 31 kilograms. My handwriting is a bit bad. Equals 31 kilograms. Okay, it's like saying 6 plus 1 equals 5 plus 2. It's the same thing. It's 7 equals 7, to be honest. So it is the exact same thing. Next slide. So what? Now we get here. Why is it important to follow the law of conservation of matter or mass? Well, it is really important so we can have correct proportions of reactants and products. Okay, now we say, why should we have correct proportions, correct amounts of reactants and products? Imagine you're baking a cake, right? You use, I don't know, flour, you use sugar, eggs, milk, salt, and baking soda, right? You put them in a bowl, mix them up, and then put them into the oven. A bit of thermal energy, heat energy applied to it, and then you get a cake, right? Now, if that cake tastes like really sour, right, then it wouldn't really make sense if you didn't have anything that tasted sour in your original recipe, right? So if you had nothing sour in your original recipe, but at the end you got something really sour as your product, it wouldn't make sense, right? So you should have had something sour in your reactants. It's the same thing here, right? We can't have, for example, 5 molecules of hydrogen on left side, and then at the end, on our product side, we only have 2 molecules of hydrogen. What happened to the other 3? How they go missing? It would be impossible to go missing. So that is the reason why following the law of conservation of mass is really important. Now we'll do some balancing chemical equations so you guys will understand why and how it's done, the basics and fundamentals of it. Now, before we actually get into it, let's talk about how to balance chemical equations. So step 1, you're going to write your skeleton equation, or aka your unbalanced equations, right? We call our unbalanced equation a skeleton equation. After that, we're going to create a little chart or a little column and write the number of atoms of each element in both the reactant and the product side, right? Our third step is going to be adding coefficients to try and balance the number of atoms and molecules for each element. At the end, when we're all done, we must always check our work by recounting the atoms, all right? So let's do a couple of examples, shall we? So here, we solved this a lot of times, or we talked about it a lot of times. So it's the process of making water. So what was our first step? Writing our skeleton equation. We have it right here. Second step was to create a chart and writing down the number of atoms one by one. So the way to make it easier for yourself is to just draw a vertical line right under the arrow. Just draw a vertical line, and then here you're gonna go. So how many hydrogens do we have? We have 2 hydrogens. How many oxygens do we have? We have 2 oxygens. So that was the reactant side. Now we go to our product side and just follow the order that we had on the reactant side. So we start with hydrogen. We start on the hydrogen as well here. So how many hydrogens do we have here? We have 2 hydrogens here. How many oxygens do we have here? Now this is the part that we should balance. We only have 1. So how do we balance it? So we have 2 hydrogens on both sides, right? But our problem is the oxygen. We only have 1 oxygen on our reactant side. So for 1 to become 2, we must multiply by 2, obviously. So we're just going to put a 2 behind here. So what happens? So the 2 is going to, make it 2 oxygen, or 2. There's an imaginary 1 here. So 2 times 1 becomes 2 oxygen. But this 2 is also going to get multiplied. Is going to multiply by the 2 down here that belongs to the hydrogen. So 2 times 2 becomes 4. Now we have equal amounts of oxygen, but we have unequal amounts of hydrogen. So we got to go fix it, right? We go here. We see, okay, what number multiplied by 2 becomes 4? It's 2. 2 times 2 becomes 4. So we put a 2. So yeah. We put a 2 behind a hydrogen here, H2 here, and now it is 4. Our last step was to check our work. So let's check it. We have 4 hydrogens here. We also have 4 hydrogens here. We have 2 oxygens here, right here, and we also have 2 oxygens right here. Now the reason I didn't put a 1 behind here, behind the O2 here, is because when there's no number behind a molecule or behind an atom, it just automatically means there's a 1 behind it. Okay. Let's do another example. This example. This is the chemical or skeleton equation of combustion of methane, right? So we have our skeleton equation. So what do? We're gonna just draw a vertical line, like a column, and we're just gonna write the number of our elements. So first of all, we start with carbon because it starts with carbon here. So we only have 1 carbon. Then it's hydrogen. We have 4 hydrogen, and then we have 2 oxygen. Here. Now we're going to follow, and that was our reactant side. Now on the product side, we're going to follow the exact same order. We started with carbon, so we're going to start with carbon. How many carbons do we have here? We only have 1. How many hydrogens do we have? Start with hydrogens there. How many do we have? We have 2 hydrogens. How many oxygens do we have? We have 3 oxygen here. So what we're going to do is that, well, we have 2 atoms that are unbalanced here. We have a hydrogen and we have an oxygen. Now the way you want to solve it is up to you, if you want to start with hydrogen or you want to start with oxygen. But in here, I'm going to start with hydrogen. Why? Because we have 2 separate O's, oxygens here. So I'm going to start with hydrogen to balance it out, and then we'll get to our oxygen. So there's 2 hydrogen here. So, and then there's 4 on the reactant side. So what do? I just add a 2 here. So it's going to change things. It's going to change this to 4 hydrogens, and it's also going to change the number of oxygens, right? Obviously. So we have 2 oxygens here, and there's an imaginary 1 down here. 2 times 1 equals 2. 2 plus 2 equals 4. Now this should be pretty easy, right? Because we have 4 oxygens on our product side and then only 2 on our reactant side. What do? We add a 2 behind here. And this turns it into 4. Let's check our work to see if we did correctly. We have 1 carbon here. We also have 1 carbon here. We have 4 hydrogens. We have 4 hydrogens here. We also have 4 hydrogens here. 2 times 2 equals 4. We have 4 oxygens here, as we see, and we also have 4 oxygens here. 2 here, and then 2 here. 2 plus 2 equals 4. So that was it. So CH4 plus 2 O2 equals CO2 plus 2 H2O. So 1 molecule of CH4 plus 2 molecules of oxygen equals 1 molecule of carbon dioxide plus 2 molecules of water. That is our balance equation. Let's do another example. That is the reaction. So here, that is the reaction of sodium with water, if you didn't know. So sodium just reacts with water, H2O, creates NaOH plus H2. Sodium oxide plus hydrogen. Sodium hydroxide, sorry, I'm really sorry. Sodium hydroxide with H2 with hydrogen. So let's try and balance it. So we're going to draw a vertical line down here. And we're going to write our elements. So it starts with sodium, Na. How many do we have? We have 1. Now it's hydrogen. We have 2 hydrogen. And then lastly, we have oxygen, which there's only 1. We're going to do the same thing on our product side. So start from sodium. There's only 1 here. And then hydrogen. How many do we have? We have 1 here and then 2 here, 3. Now I would like to separate them out because it would make it easier for me to do, but again, it's up to you. It is recommended to separate them out because there's only 1 polyatomic ion in this entire equation, that is a hydroxide. If we had another hydroxide in our reactant side, so 1 hydroxide in the reactant and then 1 in the product, then you could keep the entire polyatomic together. We'll get to that example later. But here we have 3 hydrogens. I'm going to separate now. 3 hydrogens. And at the end, we have 1 oxygen. Let's check them. Let's make sure we have the correct amount. So 1 sodium, 2 hydrogens, 1 oxygen, 1 sodium, 3 hydrogens, and then 1 oxygen. Okay, let's do it. Now we want to so now everything sodium and oxygen are balanced, but it's our hydrogen that is not balanced. So it's 3 and 2. What is the least common multiple of 3 and 2? It's 6. So we should multiply this by 3 and then here by 2. So I'm going to start by the one on the reactant side. So I'm going to put, so what do we do? Okay, but because I separated out the hydrogen here, we can't really put, use the common multiple of 6 here. So I'm going to start by putting a 2 here, right? So it changes things. If you have 4 hydrogen, right? 4 hydrogen and 2 oxygen. That's for that. But it also changes things down here, right? So we have oxygen, our oxygen and our hydrogens unbalanced. So I'm going to put a 2 here to balance everything out. So it changes everything, honestly. So this makes it a 2 here, 2 oxygen, and we're going to have 4 molecules of hydrogen in total because 2 here and 2 here. That becomes a 4. So as of now, we have our hydrogens sorted, but our sodium is not sorted, which it's pretty easily solved. We're just going to put 2 here, and that becomes a 2, right? Let's check how it works. 2 sodium here, 2 sodium here. 4 hydrogen here, 2 times 2 equals 4. 4 hydrogen here. So 2 here and 2 here becomes 4. We also have 2 molecules of oxygen here, 2 here as well. So we solve this. So it's really important to pay attention to polyatomic ions and to separate them out in the right time. And if you do separate them out, take the precautions and solve the equation carefully. We're going to do one more example. So this reaction here is called the precipitation reaction of barium sulfate. So we're going to solve it, right? So here it's sodium sulfate reacting with barium nitrate to give us barium sulfate and sodium nitrate, right? So we're going to go solve it. So we're going to draw a vertical line here and we're going to start writing it out. So we have sodium here. How many do we have? We have 2. Now let's pay attention to this. It's SO4, so there is one polyatomic here and there's another polyatomic here. They are identical polyatomic ions on both sides of the equation, so we tend to keep them together. I would not recommend trying and separating them up. I would keep them together. So I'm just going to write SO4. There's only one. And then barium, there's only one again, Ba. There's one. And then same case here, nitrate, NO3 nitrate. There's one here and there's another one here. So I would keep it together. I would not separate it. So NO3. There's 2 of them. We're going to do the exact same thing here, but going in order. So we're going to start with sodium. There's only one sodium. And then SO4 sulfate. There's one. And then barium. We have one. And at the end is our nitrate. Oh. Nitrate. We have one. Let's check to make sure we wrote the correct amount. So 2 sodium here, 2 sodium here. One sulfate, one barium, and then 2 nitrate, 2 nitrate. So 1 sodium, 1 sodium, 1 sulfate, 1 sulfate, 1 barium, and then 1 nitrate, 1 nitrate. So we have our sodium and our nitrate unbalanced. So there's two of them on the reactant side, but there's only one of them on the product side. So we just have to add a 2 simply here, and that would be it. As simple as that. So that changes into a 2, and this also changes it into a 2. Let's check out work. 2 sodiums here, 2 sodiums here, 1 sulfate here, 1 sulfate here, 1 barium here, 1 barium here, 2 nitrate here, 2 nitrate here. So it was as easy as that. So the key to solving these equations and the tips and tricks to solving these equations is to start with the most complex molecules, such as polyatomic ions, as we saw here. Okay, because if you start with small molecules and work your way up to the big and complex ones, then you're going to get everything wrong and it's going to get messy, and you might have to redo everything. Second thing is to balance one element at a time, as you saw me doing. So I started with one element, I solve it, and I went to the other element. I fix it, I went to the other one. Fixed that one, went to the other one, and my equation was balanced. And the most important tip here is to check your work at the end to make sure you have correct proportions at the end. It is really important because it is really, really easy to make mistakes in solving chemical equations. So we must always check our work at the end. Thank you very much for listening. So that was the end of our lecture on balancing chemical equations and law of conservation of mass. Please feel free to post any questions or just write down your questions in the comment section, and make sure you subscribe so we can grow our channel and learn more things together. Thank you very much.